So hello everyone, today we are going to talk about 5G technology. We'll be looking into the surface or general overview of 5G technology and how it has been taking place in the common scenario. So as you might have heard about 5G is technology, is a communication technology where it has been upgraded. Right now worldwide there is a certain 4G technology being taken place around the world, but 5G is upgraded version of it. If you look into the slide this way, then as we can see that uh, analog telecommunication was introduced on 1979, around 1979, and it was 1G. It was analog telecommunication, and we have our landline phone, right? This is the analog, and this is called 1G. So if you go uh, if you go further forward, then around 1991 text messaging came, and it was this uh, era of 2G networks, because text messaging was not possible on our landline phones. Later on, internet connection, wireless internet connection, and mobile mm, mobile communication was there, and around 1998 it started, and it's also called the backbone of today's internet. So around 1998 3G technology came. After that, around 2008 4G technology came, where cloud, IP, and truly mobile broadband, those specific features help to upgrade the telecommunication technology in those fields, and we call it as 4G. As you know, in 4G enabled SIM you can play, you can have a multiplayer games. You can play multiplayer games also. I think you also can do FaceTime in it, right? So these are the also not just IP, VoIP feature was also introduced with 4G. So why 5G? Like, is it the thing just like features are being added on these telecommunication technologies, or it's just a convention that happens with some small changes? I think it's not that. Actually, 5G is certain technology that has I can show you the next slide, which has the features, or let's say what things are being differentiated out 5G. But as it says, unlimited data capacity will be enabled by 5G. As we know that hardware technology has been upgrading, and so as hardware upgrades, as our internet bandwidth, or let's say as the limitation of hardware increases, then software or telecommunication limitation also should definitely increase. So that's the result of hardware advancement. Due to that, this trend goes on like forever. Hardware becomes more stronger, telecommunication and software becomes as per the hardware. So if you look into the 5G, then we can see that 5G will differentiate itself by delivering various improvements. Like, it will decrease the latency by 10 times. The latency will be decreased. We know that delivering latency as low as 1 millisecond. It will have a connection density which will be more than 10 times more than 4G network, enhancing more efficient signaling for IoT connectivity. Because connection density means, in IoT network, for example, in a house, if you enable IoT devices, then in a certain single house there will be multiple devices. So your connection density must be more enough to sustain multiple devices in a particular area. So that's what connection density means. Spectrum efficiency, 3 times the spectrum efficiency will increase. For example, achieving even more bits per hertz with advanced antenna techniques. So bits per hertz will be, it will be increased with 5G, and it will be 3 times more. 100 times the traffic capacity will be increased definitely. Diverse network hyper densification with more small cells everywhere. 10 times the experienced throughput will be increased, bringing more uniform multi GB per second peak rates, and 100 times the network efficiency will be increased with optimizing network energy consumption with more efficient processing. So these are the areas where, or the areas where the daily 5G will deliver improvements. So I think you got the point, like how the technology has been advancing, how the telecommunication has been advancing, and what areas will get. And so this is the backbone of any communication system or telecommunication system. This backbone will create other features in technology. Hardware will be improved, software will be improved. So that's the that's what I was trying to convey here. Okay, so if we see at the components of 5G, then there are multiple components of 5G. One of the component is a spectrum. Definitely 5G spectrum has certain range under which the 5G the 5G spectrum, or let's say 5G bandwidth will work on. So we can see the image of 5G NR unified design across diverse spectrum bandwidth types. Another component of 5G is small cells and picocells, low power base unit used in LTE advanced version, and 5G technology to power devices in a small geographical area like few hundred meters up to 2 kilometer radius. So small cell picocells will be there. These are the small cells, this is a picocell. So there are multiple devices, and all these small cells and picocells will be aligned as in a more dense dense area. So 5G has another component called small cell and picocell, and first component is a spectrum. Definitely every kind of telecommunication system has its own spectrum, so 5G also must have its own spectrum, small cell and picocell. Massive MIMO. Massive MIMO means so full form of MIMO, I'm not sure, but let me just search here. Okay, I'm sorry for that because I prepared this slide MIMO in 5G. I think a year ago, year and a half ago, and I just want to restate these things. So I forgot the full form of MO, but MIMO means full form of MIMO. What is MIMO? So MIMO is used in 4G and 5G. With 5G cellular or new massive MIMO will boost bandwidth to user and support more user per antenna by incorporating large array of small antennas. But multiple input, multiple output. So MIMO means multiple input, multiple output. So used to increase data rate with addition of antenna for transmitting and receiving signal. So transmitting and receiving signal, multiple input, multiple output. Large number of miniature size antenna arrays are used in 5G technology. Miniature size antenna arrays will be there. So let me again look into Google Images what kind of image I can find, and I will drag here if I find any of those multiple array. Role of massive MIMO in 5G. So I think I got a certain Medium article here. Let me show you here. So it says a role of massive MIMO in 5G. What is massive MIMO technology? MIMO stands for multiple input, multiple output. Illustration of massive MIMO for 5G. Boiled down into one principle, MIMO spatial multiplexing is the simultaneous use of the same radio frequency to transport different signals. So okay, so MIMO matrix source also can be seen. And why do we need massive MIMO for 5G? Then coverage capacity, use antenna. So however, there are some obstacle in massive MIMO. Use antenna will be the device capability will be as per the 4x4 MIMO is current mainstream technology, but if you bring 5G, then I think we might require a bit more device capability must be increased, and there will be trade war. Obviously trade war, adoption of massive MIMO requires close collaboration between network equipment maker and device supplier. So all these things are there where all this 5G technology is not that easy, because it touches multiple multiple parties, where telecommunication companies, device maker company, network equipment making company, all those should come in place. So due to which I think Huawei was banned from US later in I think 2019, because Huawei's all these telecommunication companies were using Huawei's antennas, or let's say their devices, and while planning, or let's say while developing 5G technology in their countries, but later on they suspected China for having some sort of backdoor in those devices. So they what they did is that they cancelled, or let's say they banned Huawei from Western countries. So that was the news that you guys might definitely heard about it. Another component of 5G is beamforming. So beamforming is a smart technology concept to efficiently transmit data to user devices. Precise location of the user device is continuously tracked using advanced software algorithms, and base station transmits signal in the direction of the user location. So beamforming, like I prepared this slide, and I was more than clear when I was giving in my classroom, but I think I forgot now. But you guys just can see about beamforming in other sources. But yeah, but no, let me just see. Okay, beamforming. Bear with me, guys. I'm sorry for that. Spatial filtering is a signal processing technique which is a sensor array for directional signal transmission or reception. Okay. So so beamforming means 1 antenna, 2 antenna, 4 antenna. There is an image of beamforming. Let me show you right now. Okay, so Huawei Technologies has given its certain definition kind of thing on what is beamforming. And beamforming means spatial hole, there will be beamforming. So this is a sinusoidal wave, and these are superimposed with each other. Okay, I think that's what it says, superimposed. So explicit beamforming will be there. So basically beamforming is one of the component of 5G, and with beamforming parameter is very shape of light becomes produced with the flashlight is busy, and the flashlight produces light beam in the same direction. The two light beams are superimposed, thereby increasing the beam brightness and changing the beam shape. Got the point, man? Got the point. Signal and the light beam will be superimposed, and they will create a certain superimposed beam. So that's what beamforming in short. Okay, so let me clear the concept for you guys. And full duplex mode of transmission is obviously should be there for autonomous car, VR, gamers, and definitely advanced hardware and software for 5G. So the receiver part or the users handheld device also must be 5G enabled. So that is also one of the core, one of the important components of 5G. Let's move further in our topic, and let's see to this slide. Now whole new lineup of infrastructure will be needed to support this latest wireless generation. Devices must be there in the 4G phones will not work in 5G networks. 5G should have its own 5G enabled devices. Network access will be stronger. 5G network require many small cell sites, roughly the size of pizza box. So roughly the size of pizza box will be those small cell sites will be there, built in close proximity to one another to improve network density in urban areas. And there is carriers. So shift of 5G will be a huge investment, but telecoms operators and carriers are considered partners to the speed of the rollout and help maximize returns. So I think I should now play the slide because of the various reasons. I think you guys might have faced that also. So but the thing is that my slide will be cut, so I think I have to cancel this plan and move back to this slide. So so device network access and this kind of line knobs should be changed if we need to integrate 5G infrastructure in any place. Devices must be there ready, network access must be on the size of pizza boxes, this must be in the close proximity, and this network access means the towers of 5G will be in very close density, line of sight, more close than any networks, just like routers. It should be just like routers, and carriers like for example telecom partner like Nepal Telecom, these are the carriers. Those carriers also have to have a huge investment plan to bring 5G technology in any sort of place. So Why 5G? Why is everyone talking about 5G? Like, we got the point what 5G will do, what kind of components does 5G have, what kind of or how the 5G has been evolved, we also know that, but what's the exact application of 5G? So there is a certain triangular triangularization in the need of 5G. For example, at one end there is enhanced mobile broadband at one end of the spectrum. At another end there is massive machine type communication, and there is ultra reliable and low latency communication. So more critical, mission critical application, example in health, example in remote surgery, ultra reliable, that will be ultra reliable application. The latency must be really low in that. So if the latency becomes a bit higher, then those kind of critical application cannot be performed. So 5G, some part of some kind of 5G will have only very low latency, very ultra reliable 5G also might be customized in that way. Another kind of 5G can be customized in like more broadband. So if the broadband is more, then you can watch 4K videos really fast, gigabytes in a second. The data will be transmitted in lots of bandwidth. So enhanced mobile broadband is at another part, and there is massive machine type communication. So it relates to more density and more your the pizza box kind of thing we just studied on a previous slide. Like the cells and picocells, or let's say your small cells and picocells must be in close proximity for this kind of application. So depending on those spectrum, there are lots of application of 5G communication: smart home, IoT devices, voice, e-health, self-driving cars, industry automation, augmented reality. All these things we have been hearing about it, and in recent days the changes has been coming through. So what's the timeline of wireless generation? So if you just step back a bit, we know the application of 5G, we know how the 5G works, but let's just see a bit in more different angle. So if you look at the timeline of wireless communication, from 1982 analog 1G, world wide web came, digital 2G came where SMS MMS was enabled, 3G smartphone era was there where 3G network go online, support high quality audio video, that was 3G smartphone era. 4G streaming era, so 4G is also called the streaming era because 4G and LTE supported HD video streaming is deployed in Europe and later in the US. So bandwidth was like 2 Mbps to 1 GB per second in 4G, but in 5G what will happen is that bandwidth will be like 1 GB to 10 GB per second, and full speed ahead to 5G. So South Korea first launches 5G across the country, China then launches 5G service across 50 cities, and then US, UK, Germany roll out 5G on limited basis. At first South Korea came in 5G game, after that China brought 5G in 50 cities, and then only the US, UK and Germany rolled out 5G. So if you look at the bandwidth, then it's directly, like, just look at this, 10 GB per second is the bandwidth. In 4G it was 1 GB per second, 3G it was 2 MB per second. So with this highest bandwidth ever, you just can just definitely guess what kind of application does such bandwidth network will support. So we were just discussing about that in our previous segments, and now what we will be looking into is the 5G generation of mobile network is here, and it's expected to have a bigger impact on global economy than any previous iteration, contributing more than 13 trillion to output worldwide by 2035. According to the forecast, China is said to see the most economic gains from the rollout, while manufacturing will be the sector that will benefit most as operators are able to ramp up production and create new revenue streams as a result of industry digitalization. So 5G will like completely complete the digitalization of the industry of everything. This data has been provided exclusively by the Informa Tech's newly formed research and consultancy business and in partnership with the upcoming 5G World event in London. So 13.2 trillion of global sales is predicted, 5% of global real output, and 22.3 million jobs generated by 5G value chain by 2035. So if you go into the next slide, then IoT is we have already learned on one of the spectrum that IoT is touched by 5G. Here IoT device, smart city IoT, has been touched by 5G. But what actually is IoT? So there are three more components, but as this slide shows that there are three components. One is AI, one is 5G network, and there is big data. So 5G is one of the core component of IoT. To empower IoT, network part must be really stronger. It has near zero latency for real-time data processing and extremely fast. So such kind of network is provided by IoT, like by 5G, and that's why the goal of IoT will be succeeded by 5G network. So if you go in more detail, like if you want to go in more detail for your application of 5G, then as we have already discussed, low frequencies are ultra reliable and low latency communication. Another part is low frequency with good coverage are massive machine type communication. So your massive IoT connections will come into the play. If you look into the ultra reliable and low latency communication, then self-driving car, mission critical application will come where the frequency is really low. But at one of the end, it's called enhanced mobile broadband, which is also called EMBB, which has really high frequency and wide bandwidth. So this application, all these kind of application are customized according to what kind of trade-offs you are doing with the 5G. Low frequency with wide bandwidth comes under this segment: smart home, smart data centers. So low frequency, wide bandwidth obviously, but high frequency with very high bandwidth comes for 3D video, UHD screens who can play in the cloud. Also, yeah. So this probably gives us a lot of idea on how the 5G is being applied on day-to-day activities, or let's say the application of 5G can be really understood with this slide. Now, so we have high quality voice and SMS from 2G. We solved that problem with 2G. We solved video, voice and data over the communication pipeline from 3G. We solved massive mobile data streaming from 4G. If you integrate 4G and 3G, it will be a gigabit LTE. But if you have 2G alone, it's called LTE IoT. So if you combine this with ultra low latency and ultra dense deployments, then 5G is developed. Like 5G is the output of that. So it doesn't means that we are like abandoning completely our previous technology and we are developing something new, but it's not that. We will be integrating those previous technologies. We will be bringing some new changes on those technologies, like ultra low latency, ultra dense deployments, and with these things we will be integrating, and the 5G network will be 5G network will be built in that way. So if you go to the next slide, then we can see that 5G enabled sales by industry. This is more of a industry related slide. Let me zoom this image a little bit. Sorry for that. I will just read here. Potential global sales activity across multiple industry sectors enabled by 5G based on a 2016 sales benchmark. Agriculture, forestry and fishing, share of industry sales 5.3%, sales 389 billion. So I don't know why I kept the slide, because I think at that time when I was preparing this slide, it was it used to make sense, but I'm not getting like I didn't understood. So let me skip this part. Let me just go to the next part, where estimation, trial and adoption of selected 5G use case. Like for common use, like for smartphone, 2019 has already done that. On 2020, so heavy use part come from 2024. Common use is a blue one. Initial use trials are the red ones. So initial use trial in the smartphone 2019 has already been done. In 2020, energy utility monitoring, autonomous vehicle and drones segments has already been initialized and trial has been already done there. In AR VR 2021, I think AR VR was already performed on 5G network. But common use now, smartphone in common use has been done in 2022. Smart cities has been in trial on 2022, starting on 2022, and industrial automation has already been started on 2022. In this way, you can just see how the 5G will be progressing. At first, smartphones will come, common use case will come, but like the initial user trial will be there, and on those segments, it will progress slowly. But yeah, it's a recent technology, because just from 2019 it has been started. So a lot of things are there to happen on 5G. So if you look into this slide, then 5G related jobs, it's talking about 5G related jobs. 5G enabled employment in millions. So this is the 5G enabled employment. 5G enabled gross output is this, and share of value chain, R&D, and okay. So you can see the US and China are really competing on these both segments. 5G enabled gross output has already been on the side of China, whereas 5G enabled employment has already been on the side of China too. But R&D has been done by both countries on same equal level. You can see France, Germany, UK, South Korea, and Japan are also equally participating in development of the 5G, and these leading countries will be so this is the 2035 prediction. So this is the 75% of all investment based on based on estimated economic activity in the 7 countries, expected to be the 4/4 of 5G development, representing 17% of all investment. So I already discussed about the Huawei incident that took place in 2019, why the Huawei was banned from US and European markets, because the devices from Huawei were expected to be, the data from 5G devices will be used by all sort of controversy that was there. We don't know, but yeah, that things really matter, because these are not the just hardware devices, or these are not just the communication channel. It's all like the entire country's telecommunication will be relying on these hardware providers. So it's a really big decision for any country to start, or let's say to design and start the work of 5G. And since we have already learned that 5G Chinese market has been doing really good in 5G development, so we can see that Chinese brands make waves in global smartphone market. And yeah, definitely Huawei has been increasing its revenue, or let's say global smartphone shipment by the top 5 vendors. And I think Huawei surpassed iPhone on 2018, so and that was a really chaotic for all. I think those also were the scenarios because of that. So this is the Huawei, just the context, what was it doing in 2018, and smartphone market was like really all being overcome by Chinese companies like Huawei, Xiaomi, and Oppo. Also, if you look into the other slide, then Huawei leads VoIP and IMS revenue. Also, yeah, definitely, because one of the major equipment provider, service provider, VoIP and IMS equipment revenue shares worldwide in 2017, and on 26% was really controlled by Huawei. Nokia only 20%, Ericsson 21%. So Huawei leads VoIP and IMS revenue too. So I think we due to this reason, Huawei was a bit controversial, so it was banned also. We can just make guess. Huawei tops international patent filing in 2014. So yeah, definitely it was like international patent filings under international patent application filed under the Patent Corporation in 2014. Huawei was leading on international patent filings. Definitely for the development of 5G, I think Huawei was doing research from early 2000s, 2005, and I think because of those reasons, the patents are also high for Huawei. And if you look into the other slide, I think second last slide for today. Multiple slides are there. Smartphone market share, others. Huawei has been coming in really close calls with this. Already surpassed Apple's, and I think it was going to as if Samsung. Huawei and 5G, the growing Chinese technological threat to US. So I think dominance of cyber and telecom. So it's really these things really matters, because it's like a backbone of any country's communication system. 5G. So yeah, these countries are confirmed network. These countries use 5G. These countries are kind of testing with Huawei's technology, and these countries have totally banned Huawei. So these countries, pink countries, are on the testing more. These countries has already used Huawei. So yeah. Also, the global telecommunication equipment sales for Huawei was increasing, as we can see from 2015, 16, 17, 18. Nokia was decreasing, Huawei was increasing. And also, finally, I think the final slide is number of operators investing in 5G worldwide by status of. So number of operators like telecommunication operators evaluating, testing, trialing in more than 133 operators are there. Deployment, already 13 operators have deployed 5G. 5G deployed in networks 55, planning 27, license to test 5, license 60. So this is the present context of 5G. I think I made this slide on 2021 or 20, I don't know, but yeah, I think I made it on 2021. So things are more like relatable in 2023 February also. But yeah, this is how, this is what 5G technology means, and like how the global socio political impact of 5G has been happening in the world, and also how the technical core components have been defined, how have been defined in 5G, what kind of application are are covered by 5G, what kind of you know deliverables, what are the deliverables of 5G. We learned a lot of things today. So with this, I just want to thank everyone who watched this video till now, and thank you guys for watching. Just comment anything you want, just let me know how the video went. Just, I think I made a lot of mistakes today because I didn't know even about the full form of MIME, beamforming, these things. We just do Google because why not, right? So with that, I will let me in my video for today, and thank you guys for watching.